Okay, so after the discussion of diffusion and their factors, and also like we did like the melting and boiling and all of this stuff. So and then also we did
Mhm.
the, can say the MCQs in the last class. So today we are going to discuss the theoretical portion of this chapter. Like if you can see this, this is two students set up tubes as shown. So in tube one, you have cotton wool soaked in concentrated hydrochloric acid, and in tube two, cotton wool soaked in concentrated hydrochloric acid. The same thing. Um, they are saying concentrated hydrochloric acid produces fumes of hydrogen chloride, and concentrated hydrobromic acid produces fumes of hydrogen bromide. 4 minutes after setting up the experiment, the litmus paper in tube 1 turned red. 7 minutes after setting up the experiment, the litmus paper in tube 2 turns red. Use the kinetic particle theory to explain how the gases move through the tube. Yes. And
Okay,
remember,
so
this is Cl and this is HBr. Like the formula. I'm talking about the formula. This is HCl and this is HBr. So first of all, obviously you need to find out the molecular masses of the two compounds, and then you would be then like you can say solve the question. So first of all, you need to find out the molecular masses basically.
okay, so
Periodic table.
yeah. So, is it okay if I open a new tab and look at the periodic table?
Yes, exactly. So you're supposed to open the periodic table and then look at the masses, and then you are supposed to add them up and then to get the molecular mass of the two compounds.
Okay. Okay. So the first element is it's hydrochloric acid.
Mm-hmm.
So it will be what is it? And chlorine, right?
Exactly. So just you can see the atomic mass of hydrogen and chlorine. So hopefully it would be 1 and 35.50. The mass of hydrogen is 1,
Mm-hmm.
chlorine
So
that is
it will be 36. It'll be 30.
exact
It'll be yeah. It'll be 36.
exactly. So this would be 30.5. And what about AR?
Let me check. Hydrogen and Dr would be what is it? Bromine.
Exactly. I think bromine is 80 something, 81
Yeah,
or
yeah. No, it's 70. Yeah, it's 79.9, and hydrogen is one, so it'll be 80.
81,
80,
right?
81.
Yes. So use the kinetic particle theory to explain how the gases move through. Basically, like I can say that this is HCl, which is producing this gas HBr,
Mm-hmm.
and this HBr. Okay, so it's going to travel just like this and reaching towards this litmus paper in 5 minutes. And
Mm-hmm.
also about this, they are saying that it reaches to the litmus paper and it's going to take 7 minutes. They have mentioned the time. They have mentioned the time. Why it's taking 7 minutes? Why HBr is taking 7 minutes and HCl is taking, you can say, only 5 minutes. So basically depends on the molecular mass. So the molecular mass for HCl is 36.5. That is the lower mass compared to the HBr, that is 81. It's having higher mass. Obviously, this is the reason it's going to take the more time. So the thing is, they are saying that use the kinetic particle theory to explain how the gases move through the tubes. So why? Can you tell me why the gases move through the tubes, or you can say that why the gases move freely, why the gases move through the, you can say, the in the container. So like what's the reason why they are going to move? So obviously you know that they are going to diffuse basically, due to the diffusion, basically, if there is a, like you can say, cotton wool soaked in concentrated hydrochloric acid. So in this area in this area we have high concentration of HCl, and in this area we have high concentration of HBr, high concentration of HBr. So I told you that the diffusion is when there is a movement of particles, from higher concentration to the lower concentration. Diffusion is the one in which the substance moves from higher concentration to the lower concentration. This is the reason the gases are moving from higher to lower, just like that, and reaching the litmus paper, and the litmus paper is gonna turn its color. So it's just due to the diffusion. Same goes with HBr. It's also like going to reach the litmus paper, and the litmus paper is going to change its color. So basically, it's also due to the diffusion. So what I'm supposed to write basically, the particles, the gas particles, the gas particles move, move from, move due to the diffusion,
Mm-hmm.
due to diffusion, as they travel from higher concentration to the lower concentration,
Okay.
higher concentration to the lower concentration, because particles have a random movement. So when they have a random movement, so obviously you can say that they would be moving from higher concentration to the lower concentration. Okay, and this whole process is due to the diffusion. So why the gases take different times to reach the litmus paper? Why they are going to, like, why they gonna take the different time? The one is HCl, another one is HBr. Should be the same. The time should be the same, but they are saying that why the gases take different times to reach the litmus paper. Like, what's the reason? Like, what do you think? What should be the reason?
Is it due to the mass of each part, each like element, or
Exactly.
yeah,
So they have different molecules.
um, molecular mass?
Okay, good. Then see this question.
A gas syringe is filled with 80 centimeter cubes of hydrogen chloride at 20 degrees. The syringe is placed in some hot water at 50 degrees. The atmospheric pressure does not change, but the volume of the gas in the syringe increases to 88 centimeter cubed. Okay. Use a kinetic particle theory to explain why the volume increases. Okay. Mm-hmm. Okay. It's something to do with heat. The more heat means the maybe the particles move a bit more like apart and they expand.
Okay.
I'm, I'm not really sure.
Basically, kinetic particle theory. according to the kinetic particle theory, remember the temperature is directly proportional to the volume. The temperature is directly proportional to the volume. When the temperature increases, so they are going to collide with each other. They are going to push each other basically. As a result, the distance between the molecule is gonna increase. So basically, and also I can say that the pressure is inversely proportional to the volume. These 2 points are very important point, but in this question you are just supposed to memorize this point. The temperature is directly proportional to the volume. As you can see that in this syringe, the volume is 80 cm cube, and you can say at 20 degrees Celsius. So in other syringe, you have increased the temperature up like from 20 degrees Celsius to 50 degrees Celsius. Then you can see the volume has been increased by 8. So right now it's 88 cm cube other than 80 cm cube. So basically we are observing that after increasing the temperature, the volume is going to increase. So we have to give the possible reason that why after increasing the temperature, the volume is going to increase. So you can say that after increasing the temperature, after increasing the temperature, after increasing the temperature, the particles started to move fast, started to move fast. So they have high kinetic energy.
Is this a chemical change or a physical change?
This is a physical change. It's not going to form the new products, but it's a physical change.
Okay.
And they have higher kinetic energy. Okay, so when they have a high kinetic energy, so obviously they will push each other, push each other. The molecules goes further away from each other, further away from each other. Okay, because the space between the molecule is gonna increase. So I can say that this is the reason the volume has been increased. This is the reason I can say that the volume has been increased. Like if you can see this, we have a smaller, you can say, um, like if you can see this, this is a
Yeah.
solid, right? This is a solid. So I'm going to, you can say, so I mean to say that when I'm going to increase the temperature, so you will see, you will observe that the kinetic energy of the particle is going to increase. When the kinetic energy of the particle is going to increase, so obviously you will see how the volume is going to increase. How the volume is going to increase. Right now, they are compact together. Basically, they are tightly packed together. They have a smaller volume. But see this, I'm going to increase the temperature. See this.
Mm.
Basically, same goes over here. Same goes over here in the syringe, basically. So this is the reason the examiner was asking at 50 degrees Celsius, we have a volume that is you, but we have increased the temperature to 50 degrees Celsius, like it's increase in, like you can say that the increment is of 30 degrees Celsius. So after increasing the temperature, we are observing that the volume is going to increase up to 88 cm cube. So this is the possible reason that I have written. Are you getting
Yeah. Yeah, I get you.
good? See this. See this.
Student sets up a tube as shown in the diagram. Cotton wool soaked in hydrobromic acid. Cotton soaked in aqueous ammonia. Concentrated hydrobromic acid produces fumes of hydrobromide. Concentrated aqueous ammonia produces fumes of ammonia. After some time, solid ammonia bromide appeared on the wall of the tube at point X. Use the kinetic particle theory to explain this result. Um, I think maybe the the molecular mass of cotton wool soaked in. I mean, maybe the mass of aqueous ammonia is maybe less, so therefore it took less time to travel,
Yes,
while hydrobromic acid took a bit longer, so it would be near hydrobromic acid. That's why it's.
exactly, exactly. So you are supposed to find out the molecular mass first. Like this is ammonia, NH3, and this is HBr, and this is HBr. And obviously that you got an idea that this tube that they are saying that it's going to travel faster, it's going to move further away as compared to this HBr. So obviously the mass of ammonia should be lower than that of HBr. But when you are going to calculate the molecular masses, so obviously you would be getting NH3 is equal to 17 grams and HBr would be equal to 81 grams. We have just calculated the mass of HBr. Can you
Mhm.
confirm the ammonia is 17 or not? Yes.
Yeah, I'll do it now. So ammonia.
Okay, yes, this is 17, right? So yes, this is the as compared to HBr. So obviously ammonia would be diffusing faster. So then use the kinetic particle theory to explain this result. Use the kinetic particle theory to explain this result. So what you would be writing down basically, like what's your words, like key points, key terms that you are supposed to write. So just write it.
Um, should I tell you? Should I say it?
Yes, yes, yes.
So due to having a less molecular mass, um, aqueous ammonia would diffuse faster than hydrobromic acid. Um, therefore, therefore the it would take less time for that to diffuse, and bromine hydrobromic acid would take longer, and it would
Okay.
be closer, and where they collide would be closer to hydrobromic acid.
So basically, or you can also write down, like let's suppose you can say that uh, uh molecular mass of molecular mass of ammonia is smaller than HBr.
Mm-hmm.
So ammonia molecules have enough energy to escape, or you can say enough energy to diffuse from higher concentration to the lower concentration.
Mm-hmm.
higher concentration to the lower concentration, and the solid is formed near to HBr, near to HBr.
Yeah.
As HBr is having as HBr is having higher molecular mass, so not gonna diffuse faster.
Mm-hmm. Okay.
And it's taking
Longer, yeah.
lower
Mm.
distance. Okay, I'm not supposed to write it down basically. I'm just writing because of you, that you wanna, like, you may understand that what the process is going on in
Mm-hmm.
this question. Okay?
Mm-hmm.
Now,
Okay, so a gas syringe is filled with 70 centimeter cubed of ammonia gas. The pressure on the plunger is increased. The temperature does not change, but the volume in the syringe decreases to 60 centimeter cubed. Mm-hmm. So a gas syringe is filled with, okay, ammonia gas. The pressure on the plunger is increased. Okay. All right, I think I understand why. Use
okay.
the calculator, volume decreases.
Yes. So let's suppose, like this is, you can say, uh, let's suppose these are the particles of gases, or you can say liquids, just like that. Let's suppose right now the volume is 5 cm cube.
Mm-hmm.
Let's suppose I'm going to apply the pressure. I'm going to apply the pressure. So
Yes.
when you are going to apply the pressure, so obviously it would be just like that, just like that, just like that, just like that. So obviously these molecules are coming close to each other. Am I right?
Yeah.
And these molecules also started to go down just like this. And
Mm.
then, okay, so I can
Yeah.
say that when the distance between the molecule is going to decrease, when the distance between the molecule is going to decrease, obviously the volume is going to decrease. As if you can see both syringe, like you can say this is at a lower pressure, like the normal pressure, and the volume is 70 cm cube, and now they are going to increase the pressure just like that. So obviously the volume is going to decrease to 60 cm cube. So there is a difference of 10 centimeter cube. Then you have to explain why, like the why the volume is going to decrease. Basically it's of only one
Mm.
mark, of one mark. So what you are supposed to write, so uh, you would be writing when the pressure is increased, when the pressure is increased, when the pressure is increased,
The the
the
space
molecule
between the particles.
come close to each
Okay.
other.
Yeah.
Exactly. When the pressure is going to increase, so the molecules are coming closer to each other.
Yeah, the space between the molecules get closer. Yeah.
Increasing the pressure.
Mm-hmm.
Okay, come close to each other.
Yeah.
See this.
Sample of neon has a volume of 21 decimeters squared cubed, at room temperature and pressure. The temperature of the sample is increased, the pressure remains constant. Describe and explain using kinetic particle theory what happens to the volume of the sample. Okay.
Sample of neon has a volume of 21 decimeter cube at room temperature and pressure. The temperature of the sample is increased. They are going to increase the temperature. The pressure remains constant. Describe and explain using kinetic theory what happens to the volume of the sample. First of all, you are supposed to tell me, is this like would it increase or decrease?
Um, the temperature the temperature is directly proportional to the volume.
Volume.
So yeah, if the temperature of the sample is increased, then it will increase the volume, right?
Exactly. 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 Yes. So okay, increasing temperature will increase the
The volume.
volume. As the collision is going to increase, so they would be colliding with each other. As a result, their intermolecular distance would be increasing. So I can say that the volume is going to increase, right?
Yeah.
Now see this part two. Part two.
The pressure of the sample is increased. The temperature remains constant. Describe and explain using the kinetic particle theory what happens to the volume of the sample. So the volume of the sample, it will. So the pressure, when pressure is increased, the space between the molecules is decreased. So which means that it will become smaller. It will decrease the volume of the sample.
So means that you are saying that when the pressure is going to increase, so the distance between the molecule is going to decrease. When the distance between the molecule is going to decrease, so I can say that the volume is going to decrease. Am I right?
Yeah. Yes.
Now you can see this, like let's suppose these are the molecules having greater intermolecular distances. I'm going to increase the pressure. Just look at this. I'm going to increase the pressure. So as you can notice, the volume is going to decrease. The volume is going to decrease. And when the volume is going to decrease, it means that the distance between the particles is going to decrease. The distance between the particles is going to decrease, as you can see. Now, after
Mm-hmm.
increasing the pressure, you can see that the volume is going to decrease. The time would come that they would be pulling each other in a very particular manner, just like that,
Mm-hmm.
and in excess of pressure, and then it would be just like that. So,
Yeah.
so it should be having, you can say, the controlled amount of pressure and the controlled amount of temperature and force, basically.
That's why when you try and if you close the end of a syringe and you try and like compress it, it's very hard to because
Exactly.
the mm-hmm,
So describe and explain using kinetic particle theory what happens to the volume of the sample. So the volume of the sample is going to decrease. Is going to decrease because pressure and volume, they are inversely proportional to each other. They are inversely proportional to each other. Okay. So, so this is the theory of, like, you can say diffusion, or you can say the state of matter. Okay.
mm-hmm.